Hello everyone, welcome back to MAT052. This week we're going to continue on with confidence intervals and hypothesis testing like we had done last week. And we're going to go through this worksheet and just it's just going to polish up for this one. We're just going to do identifying means and proportions and context. What the context means is the context of the problem. So you'll be given, here's a statement of what we are interested in, and a lot of times it's not very clear exactly if it's, it's not coming straight out and asking you what, give me the means, the confidence intervals for the means or something. But let's just take a look and see if we can clean up some of the confusion, okay? So in your statistics class, you will often need to determine whether a question is describing or asking about a mean or a proportion so that you can create the correct confidence interval or conduct the correct hypothesis test. What keywords or symbols might you look for in order to determine the parameter/statistic of interest? So a lot of times they will be, the question will be asking or wanting you to calculate something, let me get here, concerning the mean, and the student would be working on a proportion problem, and it's like totally wrong. So proportion, what kind of words would they be doing? They may say something like the percentage. Okay, so look out for that. If you see percentage of the study or something, that's talking about a proportion. If they just ask for P, that is the proportion, okay? X out of N. So like 2 out of 3 people, it's going to be larger samples, but 20 out of 300. Let's do that one. 20 out of 300 people prefer. You're talking about proportion, and that's the P. And if you're going to be looking like 0.2 less than P. Sorry, 0.2 less than P less than 0.3 is the kind of confidence interval we're going to do. And then if you're talking about a hypothesis test, then you're going to have something where you're going to have H0. You're going to have like P less than or equal to 0.2, versus P greater than 0.2. Okay. So the mean, they could be talking about mu. Certainly if they give you the mean, find the mean, that should be, pretty clear on that. They could also be talking about the average, the sample average, okay? Here they also could have the sample proportion. Sample percentage, but here the sample average is what you're talking about. The X bar of the sample, all of those would be talking about using this to infer back about something about mu. Or in hypothesis testing, using this to prove or disprove a statement about mu. Okay. So when reading a problem describing a confidence interval or hypothesis test, there will almost always be a percentage provided, the confidence level or significant level. While it's important when actually completing the problem, you can ignore it when trying to decide between the proportion and the means. Okay. Let's just go through some of these things. So determine whether each statement describes a mean or a proportion. Well, my average school travel time is 23 minutes. So here's that average that I was telling you about. And my average travel time is 23. So this is a particular value. Okay, it's not a percentage or proportion. Okay. So we would be working with the mean, either a confidence interval or hypothesis test. But here, that's just strictly talking about a mean. You wouldn't work into a hypothesis test on that. Approximately 52% of students, 52%, that's that percentage I was telling you to look for So this would most certainly be a proportion. So even though this is an X bar, it could be, that would be one X bar, and then you would go from there. Proportion, approximately 52% of students at a local school are female. That would be a P hat. Now, if we were talking about that's our only population of concern, then you would use P for that. Nine out of 10. Again, proportion. Okay. So let's go a few more. Determine whether each situation is asking to predict the population mean or the population proportion. So write a 95% confidence interval. This is just the confidence level. That's just the confidence level. Okay. So this goes with the confidence interval. So if I was to go over here, draw my little bell-shaped curve with my 2, 0.95 is in, the alpha is 1 minus 0.95, and then this is alpha over 2, so 0.05 over 2 here, and the area over here is the 0.05 over 2. That's another alpha over 2 in here, so if I kind of draw there. Okay, so that goes with that. That's the confidence interval that you're going to do. Okay, for the percentage of people between the ages of 18 and 25, that is the population proportion that you're going to be working with. So this piece says proportion. Okay, they will sleep at least 8 hours per night. Okay, so that would be a confidence interval. So you're going to be working for a confidence interval. You want something that has P less than 2 numbers, and that proportion is going to be between 0 and 1, right? Between 0 and 1. 0.23 to 0.25. Okay, but all of these proportion has to be between 0 and 1. Construct a 99% confidence interval to estimate the expected lifespan of a TV. 99% confidence interval, that's that one piece of it. That just says I'm confidence interval with a 99% confidence level. Estimate the expected lifespan. I would expect this to be a time, so I would be doing the mean time. Expected value, the expected average. So this is a confidence interval. This one was for proportion, sorry. And this would be the confidence interval for the mean. Okay. 99% to give our critical values. 0.99 in, 99%. Alpha is 1 minus 0.99. 0.01, and each in the little area that's here is half of that. Inside 0.99, 0.01, so this is 0.005 alpha over 2, and this is 0.005. To get our critical values, then we would go to the tables or our calculator to do the inverse and find what numbers have this much area. 0.015, sorry, 0.005, that's 0.05 here, and then 1 minus the 0.995 would be here, 1 minus that alpha. And you would have this, you would have some value less than the mean of all TVs, less than some number. So students from a statistics class were asked how long they studied for their most recent test. The results indicated an average, there you go, of 3.5 hours with a standard deviation of 0.7 hours. Write a 90% confidence interval to estimate the parameter. What are we doing? Here's the average, so it's going to be the mean that we want to estimate. So this is CI for the mean. Okay, 90% confidence. So if I go to get my critical values, but I'm actually doing margin of error, I'm going to consider 0.90 on the inside. My alpha is 1 minus 0.90 is 0.10. The alpha over 2, just divide that by 2 on your calculator, 0.05. 0.05 in there, 0.05 in there, and I'd go get my critical values here and critical value there. Okay, I only need one of these things, but that's basically the breakdown of critical values. Inverse normal, 0.05 area. If I go to A2, I would go in and find 0.05 inside and then read off the z-score. So again, population mean or population proportion. After testing 300 products made at a certain finding and finding only 2 that did not work, Ahmed expects that at least 99% of the products made in the factory should work properly. Conduct a hypothesis test to determine the validity of Ahmed's claim. 99% of the products, so that is a proportion, right? Percentage proportion. Proportion. Come on. Proportion. And I'm going to have something like P between 2 values once I work this thing out. Okay. Oh, so we're not doing a confidence interval, we're doing a hypothesis test, sorry. So we would have something in this case of at the least would be 0.99, that would be the least, at least the very least, so the P is bigger than that. And then our complement to that would be P less than 0.99. I would sign my H0 and alternate. Here's my null hypothesis, the one with the equals. And then the other one is automatically H1 or HA, whichever one you prefer. Okay. Julie claims that more than half of her class earned an A on their last test. More than half. Tester claim with a significance level of 0.05. So we're going to be doing a test, hypothesis test, and more than half. So I would say the proportion was more than half, so it had to be bigger than 0.50. More than half. Test for a proportion, because I'm talking about a piece of the whole. And then I would do, for hypothesis test, I would do the complement of this. Here's my claim. Less than or equal to 0.50 would be my complement. I would go to find my H0, the one with the equal, so I would assign H0 here, HA there. Right tail test. Test the hypothesis at 95% confidence, so this would be alpha. I'm going to do a hypothesis test, so I need an alpha 1 minus 0.95. So this is just another way of working into alpha 0.05. The average distance, test the hypothesis at that confidence level, that the average distance from work for employees at a certain company is less than 30 minutes. So that would be a time for our mean. Okay, so we're going to do a hypothesis test for the mean, about a mean. And I'm going to say that mu, here is this statement, this is the claim, that is less than 30, strictly less. Complement, mu greater than or equal to 30. And then I would assign H0 and H1. This tells us which test we're doing, less than 30, the left tail test. The less than 30 tells us the left-tailed. Okay. So here's on your own. I'm going to let you get started on these and do the submission. I've got the submission link included. I'm just going through to make sure. And we'll see you next time.